All right, this is video homework number 3. Problem 1, identify the parameters of the binomial setting in P1 minus P and explain what each represents. So in P1 minus P. N is the number of shots that a basketball player makes, so that's 60. P is the probability that she makes, or the percent she makes the free throws, and that's 80%, so 0.8. And then 1 minus P, that is the probability that she misses, so it's just 1 minus 0.8, which is 0.2. Part 2, compute the mean and standard deviation of the number of successful shots. Clearly explain what these numbers mean in context. So in order to find the mean, we're first going to start by setting mu equal to n times p. So it'd be 60 times 0.8. You plug that into the calculator, you get 48. So for standard deviation, you're going to take the square root of n times p times 1 minus p. So it looks something like this: 60 times 0.8 times 0.2, and that equals square root of 9.6. If you take the square root of that, you get 3.10. So on average, she makes 48 shots with an average variation of about 3.1 shots from the mean. Part 3, check whether the normal approximation to the binomial distribution can be used here. Show the values of np and n times 1 minus p and verify that they satisfy the rule of thumb that np is greater than or equal to 10 and n times 1 minus p is greater than or equal to 10. So all we're going to do is np equals 48 greater than or equal to 10, and then n1 minus p equals 12 greater than or equal to 10. Since the rule is satisfied, we can use a normal approximation here. So part 4, use the normal approximation to estimate the probability that she makes at least 50 shots. So p x greater than equal to 50. P y greater than 9.5. Okay. Where y in 48 3.1. So then next step be setting z equal to 49.5 minus 48, dividing by 3.1. Put that in calculator. You get 0.48. need to think for a second. Right. Okay. So now that we have that, we need to find the probability she makes at least 50 shots. So not actually sure how to do that. So I'm gonna just stop at this part and move on. Part 5, reflect in your own words. Why do statisticians, that's not right. Sometimes use the normal model for binomial probabilities, even though it's only an approximation. You use the normal model because it simplifies binomial calculations when n is bigger. The shape of the curve is becomes bell-shaped as n increases. So and the approximation is accurate when both n p and n times 1 minus p are less than or equal to, or greater than or equal to 10. Sorry. NP and n times 1 minus p greater than 10. Okay. Question 2. A population has mean equal to 60 and standard deviation equal to 12. Samples of size n equal 36 are taken. Part 1, what is the mean and standard deviation of the sampling distribution? So, question 2, mean and standard deviation of x bar. So, x bar okay, and then standard deviation x bar would equal would be 12 over 6 and that equals 2. Okay. So mean standard deviation. Part 2. What is the probability that sample mean is greater than 63? Right. So trying to find x bar is greater than 63. So to do that, z equals 63 minus 60 over 2 equals equals 1.5. Because 3 divided by 2 is 1.5. And then from the z table, p z greater than 1.5 would equal 1 minus 0.9332. I think I got all the threes. And then that equals 0.0668, which means there's roughly a 6.7% probability. Yeah, cool. All right, part 3. On a normal curve, sketch and shade the area that represents the probability found in part B. All right. And then clearly label the sample mean of 63 and the corresponding z-score. Okay. So we'll start just putting some lines in. All right. And then let's see. Let me look at the question again. Okay, so we know that the mean equals 60, sample mean equals 63. What was the last thing we needed? Corresponding z-score. Z equals 1.5. So let's see. All right, and then we will just divide these values by 100, or by, yeah, 5, 10, 15, 20, 25, 30, 35, 40. Okay. And we go up to 40 and back down again. And that's supposed to be right there. That's the center. And then 1.5, and our shaded area is all that right there. Okay. Explain how the central limit theorem allows you to use normal model for x bar even if the population distribution is not normal. The central limit theory says that the distribution of sample means, sorry, I have this written down, but I can't read. X bar becomes approximately normal as n increases, even if the population is not normal, because each sample mean averages out random variations. So there you have it. Part 5. Suppose the sample size increases to n equals 100. How would the standard deviation of x bar change, and what does this mean in practical terms? So basically, it's saying if the sample size increased to 100, what would happen? So standard deviation x bar equals 12 over the square root of 100. That is 1.2. So you have a smaller standard deviation as population goes up. Part 6. Explain how the law of large numbers relates to this situation. What happens to the sample mean x bar as n becomes larger and larger? So as n increases, the sample mean x bar gets closer to the population mean. So basically, as more like people, or just n goes up, it's going to get closer to the population mean. Yeah. Question 3. A random sample of 50 students has an average GPA of 3.15. Assume that the population standard deviation is 0.4. Construct a 95% confidence interval for the population mean GPA. Show all steps and formulas clearly. Okay, so n equals 50, x bar equals 3.15, and standard deviation equals 0.4. So part 1, equals 1.96. Let's see. Hold on just a second. Just kidding. I don't know how to do this. So we're just gonna take the L on that. Interpret your interval in context. What does 95% confidence level actually mean? Well, I don't have an interval. So, I don't know. Okay, more drawing. Part 3 says, on a normal curve, sketch the confidence interval centered at the sample mean. Clearly label the mean, the lower and upper bounds, and shade the region that represents plausible values for the population mean. Okay. Well, seeing as I don't have that data, we're just gonna move on to problem 4 because Miles is a little stupid and doesn't know how to do math. Problem 4. Soda company claims that their cans contain, on average, 12 ounces of soda. The consumer group suspects the mean is less. They take a random sample of 40 cans with a sample mean of 11.92 ounces. Assume that the population standard deviation is known to be standard deviation equals 0.24 ounces. Part 1. State the null and alternative hypothesis clearly. Is this a one-sided or two-sided test? Explain why. Okay, so we're going to start with our givens. U equals 12, n equals 40, x bar equals 11.92, and the standard deviation equals 0.24. So I'm going to start with our hypotheses, where mu equals 12 and mu is less than 12. State the null and alternative hypothesis clearly. Is this a one-sided or two-sided test? Explain why. It would be one-sided. Yeah, we're gonna say one-sided because you're testing the cans for less liquid, not more. So one-sided because you're testing for less. Part 2, compute the test statistic z and find the p-value for the test. Show all steps. So using our formulas, z equals 11.92 over 0.24 times the square root of 40. Whoops, that's not right. Z equals 11.92 minus 12 over 0.24 times the square root of 40. Okay, so we'd have a negative at 0.08 on top, and then we'd have 0.038 on the bottom, which is negative 2.11. So then we would take that, and then from the table, move 2.11. That's equal to 0.0174. Yes, Andrew.
What?
Yes, I'm recording something for class.
Oh, my bad, Quinn.
Sorry about that. So then your p-value is equal to 0.017. Decision. Part 3. At the alpha equals 0.05 significance level, what is your conclusion? Write your answer in a complete sentence in context. So at p is less than, so we reject the null. Because there's significant evidence that the mean amount is less than 12 ounces, which again we're measuring was for less, and we found that there is less, so we would reject the null. Part 4, on a normal curve, sketch and shade the area that represents the p-value. Clearly label the population mean, the sample mean, the test statistics, and the rejection region. Indicate whether it is a one-sided or two-sided test. Okay. Give me 1 second. Okay, so let's see. Okay, so 5, 10, 15, 20, 25, okay, 30, 35, 40. This is our center. And we want negative 2.1, so that's close enough. And then our shaded region is all that. Okay. What else did I need to do to satisfy this question? It's one-sided. So Part 5, conceptually, what does the p-value represent in this situation? Explain what a small p-value tells us about the evidence against the null hypothesis. P-value is the probability that you get a result as extreme or more extreme than the sample results, assuming that the null hypothesis is true. Small p-values indicate strong evidence against the null hypothesis. Problem 5. The nutritionist wants to test whether a new diet changes the average cholesterol level from the historical values, 200 milligrams per deciliter. A random sample of n equals 15 people on the diet has a sample mean x bar equals 195 milligrams per deciliter and a sample standard deviation of 20 milligrams per deciliter. Assume the population is approximately normal with no strong outliers. Part 1. State the null and alternative hypothesis to test whether the diet changes the mean cholesterol level from 200 milligrams per deciliter. Is this one-sided or two-sided test? Explain briefly. Okay. Okay, those are our two hypotheses. And because we're finding equal or not equal, it would be two-sided. Part 2. Compute the test statistic t equals x bar minus mu over standard deviation divided by the square root of n and the degrees of freedom. So t equals 194 minus 200 over 20 divided by the square root of 15. That equals -6 and 5.165. Divide that. You get a -1.16. In the degrees of freedom. So, degrees of freedom. I forgot how to do degrees of freedom. So we'll move on. Find the critical value t for a two-sided test at alpha equals 0.05 with your degrees of freedom. Decide whether to reject or to fail to reject null hypothesis by comparing whatever t bar to t. Okay, so well, I don't have my degrees of freedom, so don't know. Part 4, on a t-curve, more sketching. Awesome. Test at alpha equal, oops, reading the wrong one. Sketch and label the two critical cutoffs at plus or minus t. Mark your observed t value and shade to rejected regions. Clearly indicate why your observed t falls into the fail to reject region. All right, so okay. That's our center. What do I need to find? Sketch and label the two critical cutoffs to marker observed t value. Okay. So we'll place a line at negative 1.16. And then our plus or minus. So we'll need 2.145. And negative 2.145. There we go. That's our graph. Part 5, construct a 95% confidence interval for the true mean using the t star critical value. Explain how interval supports your decision in part 4. All right, well, I don't know how to do that either, so that's it.